viewed as a prequel to Gabriel's wonderful talk, so please bear with us. I wanted to start first. Is it okay to start? We good? Awesome. Okay, thumbs up. Great. So how many people in the room have, I am curious, like have used a large language model to generate any sort of code before? Okay, that's almost everyone. Interesting. And how about, has anyone used a large language model to generate specifically Dafny? Okay, fewer, but still a decent number. Great, so this project really was spawned from the idea that there's an underdeveloped synergy between the programming languages community and the machine learning community, as Gabe actually alluded to. On the machine learning side, we think that writing in verification-aware languages like Dafny is a really interesting testing ground for how large language models reason or don't reason about code. And also it's a useful way to make sure that the code that comes out of large language models provably adheres to a given formal specification. And on the flip side, as Gabe mentioned, we think that large language models could help automate some of the tedium, the cost associated with writing in verification-aware languages, again, like Dafny. But we have a bit of a chicken and egg problem here when we think about training systems to write in verification-aware languages, because there's just not that much data. When we look at this table and we think about neighboring tasks or neighboring problems, like mathematical theorem proving or unverified program synthesis, there are many more benchmarks with many more problems. But for formal software verification, at the time of creating DafnyBench, and there were really only two options, and those were Clover and Dafny synthesis, which are great in their own respects, but quite small. And Dafny synthesis is a bunch of MBPP Python programs that have been translated and verified with GPT-4, which shift the distribution, since these are mainly programs that we know GPT-4 can verify with Dafny. So with DafnyBench, the original mission was to increase the amount of data that was currently available in benchmark form for studying and training large language models. And in order to draw this data from a distribution that was similar to what human programmers write in Dafny, we decided to set a first stake in the ground by constructing DafnyBench by scraping a bunch of Dafny programs from GitHub. And so we basically downloaded all of the Dafny files uploaded to the site, GitHub, from before December 2023. And we filtered them, as Gabe alluded to, by checking for programs that verified as standalone files and also that weren't trivial in the sense that they had at least 5 lines of code and included at least one ensures or requires clause. We conglomerated that amount of data with the existing Clover and Dafny synthesis datasets in order to create the largest real, I suppose, benchmark to date of Dafny programs. And the task that we envisioned using with this benchmark, which was taking a program like linear search here and stripping out all of the proofy parts, the proofy annotations in the body of the program. So removing all of the invariants, asserts, decreases clauses in the body of the program without touching the ensures and requires clauses that in the header of this method, for example. And then the goal would be to have large language models add back those stripped annotations. And if the language model is able to replace those annotations with equivalent ones that make the program verify, then we consider it a success. And so this is the benchmark task.
Thank you. Yeah, so I'm going to talk a little bit about the results. This should be the most exciting slide, but it's kind of the most boring, although it might be a little bit spicier now, based on what Gabriel was saying. So we tested what was at the time the cutting edge large language models available. Cloud 3 Opus did the best with 67.8% success on the benchmark. GPT-4 Turbo and 4.0 basically tied with 59.8%. 3.5 Turbo, 44%. Code Llama, interestingly, pretty low, 28%. You might wonder, oh, is it just because it's open source and it's poorer quality? to be continued, little cliffhanger. We found out why, but it doesn't really do any better than what we found the sort of control rate to be, where you don't even use an LLM. I guess this is the spicy part. I'm not sure why it sort of disagrees with what Gabriel was saying. We found 26.9% will succeed where you just take DafnyBench and run it through Dafny to try to verify. Probably something we have to follow up on with Gabriel. And yeah, with that, hand it back to Chloe.
Cool. So we wanted to break down how models performed when they were given a chance to reflect on their answers without any sort of MTS or Monte Carlo tree search like scaffolding. We just wanted to see what happens when the model reflects for itself on the feedback provided by the Dafny verifier. So we structured this by giving a model a total of 10 attempts, and say I took GPT-4 and gave it like the linear search problem from the beginning slide and asked it to fill back in the stripped annotations. It would, let's say that it gave us its attempt. The Dafny verifier said, hey, that's wrong for some reason. We would then give that Dafny verifier error message and the original attempt back into GPT-4o and say, hey, please fix this for us. And then we'd evaluate its next attempt at the problem. So this is what the x-axis represents. It keeps track of that number of iterations, that number of attempts I just described. And the y-axis is the success rate, the number of DafnyBench programs that the model successfully verifies at that attempt number. And we see from the graph here that we experience diminishing returns after attempt number 4. The best model at this appears to be Claude 3 Opus. It takes feedback most effectively and improves until about attempt 4, and then kind of the curve flattens out. It doesn't make much more progress. It would be really interesting to look at models that are known to be really strong at proving mathematical theorems, like O3 from OpenAI, which is coming out soon. It'd be really fun to put O3 through the same analysis and see how the shape of its curve changes, if at all. We also were curious about how large language model performance behaves with increasing complexity of programs. As Gabe points out, the majority of programs in DafnyBench are quite simple, and that's partly because of the filtering process. We looked for standalone files that verified. But we implement a very, very crude proxy for program complexity, which is the number of characters in the program on the left, and then the number of characters in the annotations of the program, so the assert invariant decreases clauses in the program, that's on the right. And perhaps as expected, as the program becomes more complex, the large language model has more trouble verifying it. And to us, this suggests that large language models are okay at doing like one step of reasoning, where the annotations required for making the program verify are like echoes of the ensures and requires clauses in the method's formal specification, kind of like with the linear search example. But as soon as you have more complicated proofs that require multiple steps of reasoning or implementing intermediate lemmas in the process of building up to like a bigger proof, large language models still fall down on this front, it seems.
So we captured all the error logs for each large language model and each file, and we broke them into 9 categories because we wanted to, do a little bit of investigation here. Probably the most important ones for our purposes are code logic error, verification logic error, trivial verification, and altered specification. And then syntax issue might come up in the next slide. But to sort of draw out the distinction between a code logic error and a verification logic error, a code logic error is like the type of mistake you might make if you're writing the imperative program, where it's like an off by 1 error or something to do with a null object. And then that shows up really nicely in the Dafny error log, that like that's exactly what's going wrong. Whereas with the verification logic error, it just says failed to prove this invariant or this decrease clause, and it doesn't really tell you why. So we distinguish between those two. And it's sort of, the idea is the verification logic error is sort of the core thing we want to test for to see how well the large language models are at providing those non-errored verification logic. We check for trivial verification, which is like a type of cheating that large language models will try to come up with, and we classify that as a failure, even if it did technically succeed. and altered specification anytime it changes the ensures or requires clauses. We classify that as a failure regardless of whether it succeeds or not. And indeed, if we look at how the histogram shapes out, the closed source models, when the majority of their errors were the verification logic errors, so it's sort of like indicating the benchmark is keying in on testing the correct thing. And Code Llama mostly had syntax issues. And when we went to investigate it, it comes down to just a calendar issue. Its training cutoff date was September 2022, and all of these were run on Dafny'25 syntax, which came out in March 2023. So don't turn your nose up at open source models just from this result. We would expect, if we were to run it again on better open source models, it would do better.
Seth touches on an important limitation that's worth calling out in the section dedicated to discussion. Data contamination is a problem with DafnyBench. When we think about how closed source models with later training cutoff dates were probably trained on data scraped from GitHub, which contain solutions to the problems posed in DafnyBench, and that could artificially inflate the performance of these models on the benchmark. Gabe brought up another important limitation, which is that a decent number of programs in DafnyBench are pretty simple in the sense that implementations are almost direct reflections of formal specifications. Ideally, that wouldn't be the case in the world's most perfect DafnyBench benchmark. So ideas for mitigating this, I think Gabe touched on some. Synthetic Dafny is a great next generation of what we're presenting here, and also translating from benchmarks implemented in other languages to increase degrees of separation from what's on the internet and what we're using to test. Perhaps more importantly, DafnyBench brings up this question of what does it mean to design better error messages or better edit languages for helping language models correct themselves and do better when they write in Dafny? And this is perhaps an echo of an even broader exciting question, which is what does it mean to design languages for large language models and not only humans? For now, that concludes the discussion. Happy to take more questions, but I'll hand over to Seth to conclude with some concrete steps we've taken on applications that we laid out, hopefully, in the original version of the paper as future steps.
So it occurred to us that all the code we wrote for actually running the tests would be useful to Dafny developers if sort of captured and presented in a useful way, because we basically have to take a Dafny file, send it to an LLM API with the right kind of prompt to get it to try to verify, parse that output for just the Dafny file, run it through the verifier. If there's an error, send that back, performing that loop in what is now sort of called agentic LLMs, which is, like a while loop. And so we actually acted on that intuition and built what we're calling Dafny Autopilot, which is a VS Code extension currently available in the VS Code extension marketplace. It's a work in progress, and the way it works is if you're a Dafny developer writing your sort of imperative style code, you maybe don't know too much about the verification annotations, you can right-click and send your code off to an LLM API. You have to bring your own API token, and it'll sort of perform 9 iterations in a loop, sending the error sending 2 errors at a time, because we found you don't want to overwhelm the LLM with too many errors. They'll just sort of build on each other. We're integrated with 3.5 Sonnet v2, Gemini 1.5 Pro, and AWS Bedrock. Should have a new feature coming out soon where you can sort of specify exactly which model and AWS region you want to use. We would really like some early users, to provide bug reports and feature requests in GitHub. Just an example. Hopefully this will work in this sharing. It's not going to work. Let's see. Oh yeah. Okay. Come on. No. Never mind. I had a pre-baked, cake, a baking show example, but it's not going to work with the way we're sharing here. Another tool that we're working on, and this is being led by Max Tegmark, is called verilib.org, and it's sort of a generalization of the idea of DafnyBench, where we want to take a bunch of verification tools, theorem-proving tools, build a big database of formally verified software, and we're writing code to sort of parse it down into the spec, code, and proof components to sort of be able to generate a diverse array of benchmarks sort of related to DafnyBench in terms of challenging the model to fill in the annotations. Right now we have Daphne Cock, or are we calling it Rock these already? And Lean. We're probably going to roll out Isabel really soon. It's sort of limited in that it's a single file upload, but it'll run the verification on the server side, and if it passes, you can publish it. And so we're trying to, create a watering hole for the community to contribute to a sort of growing database of verified software. So that's all we have for now. We're happy to take questions. Thank you for your time.
So just to clarify, when you were collecting Daphne files, you said you look for ones that were standalone files, and then if there were dependencies inside the file, did you sort of identify which dependencies needed to be fed in? And if so, did you run into like context limitation problems?
We did not do that. That would be a great next step if you want to contribute to a more complex DafnyBench. No, we didn't.
So you were just looking for a file that had a standalone that would verify with no other context?
Correct.
Thanks for the talk. I know that Daphne has like an experimental feature where you can show a counterexample if verification fails sometimes. Did you incorporate that into like your procedure of passing that error message to the LLM?
Once again, we did not, and would love to see your submission to DafnyBench.
Does anyone know how to change which slide is shared or which screen is shared real quick? Since we have like a minute.
I think we're already running over time.
Oh, okay.
Pretty much. So, but thanks a lot for the great talk. So let's thank you again.